It's actually quite a casual event because we are actively looking to create dialogue with you. We have a lot of content we want to cover because artificial intelligence is complex. But we welcome your questions, and we hope we can have conversations during the break and at the end of the session as well. So don't be strangers. There's no need to just be here and take notes and go. Feel free to talk to us, yeah? So the event will last about 2 hours, 2 hours and a half, depending. So I think you, including a small break of 15 minutes or so, we have some snacks and drinks during the break. So I think you'll be finished by give or take around 6 o'clock. And the first part is a little bit more business. So we'll talk about artificial intelligence in a general sense. So this should be understandable, I think, for most people. And then the second part after the break is more technical. That's there it probably helps if you have some programming experience. But even if you don't, I think you will be able to understand quite a bit. So that's the way we'll organize it. Okay. Let me just give a few brief words about us, and then I'll go into the event. So we are part of a company called Slash. Slash is a studio where we build our own startups, and we also help clients build their programs. We work globally. Most of our clients are global. We have an office. We're headquartered in Singapore, where I'm based, and we have an office in Indonesia, Bali, and an office in Phnom Penh. Here we have around 25 people. And we do some really interesting work, including a lot of work on AI and blockchain. Yeah, we're always eager to drive the agenda in Cambodia and get more people to learn about these technologies. So today there will be a few people speaking on stage, besides myself, so I'm the CEO of Slash. We have Kevin, I think he's still running the course at the University of Leicester. So he's going to come anytime. We're running an AI course at the university, so he will come afterwards with some of the students. Then Rata is here. So Rata is a researcher who just finished his PhD in machine learning and AI in Chengdu, China. Then Rata, I think, will not be making today, but then Makara is sitting somewhere in the back. And Makara will also say a few words after. So we have a few people from our team that will say. And then you'll see there's a lot of people wearing the Slash t-shirts, so these are general people from our team. Feel free to approach them if you have questions, or if you want to get in touch for some reason, yeah? So a few words on Startup Jungle. Startup Jungle is a community initiative that we've launched at Slash. The idea is to promote, to be able to build the survival skills for the jungle of startup life. Yeah, that's sort of the tagline. It's all about building technology and business skills. So we think that there's many more companies like Slash in Cambodia that have a certain type of skill sets that they can share with the community. Whether it's agile, whether it's lean startup thinking, design thinking. It's a specific type of programming, whether it's pair programming, or it's a specific language like Java, or it's technology like AI and blockchain, or it's about payment aggregation. In short, there's a lot of different things we can teach each other and help each other with. And the philosophy is that we want to invite other companies like us to give free workshops like this. So this workshop is sponsored by Slash, because these things obviously cost money. But we think that if more companies like us do this, we can together build a very exciting community. So if you think your company will be interested, give us a sign. You can either approach anyone from Slash. Specifically, there's a guy running around. He's just at the booth there, Kong Meng, who is at the check-in booth. He's in charge of Startup Jungle, and so we're trying to promote this initiative, and we'll have more initiatives coming up. This is our number 5. We have already done 4 previous editions on AI, design thinking, and lean startup. Yeah? And we'll have one in September coming up on blockchain. Yeah? So let's start with the actual session then. I have a tendency to speak quite fast. If I speak too fast, just give me a sign like this, like do like this, and I know that I need to slow down. Okay? So, part 1. Welcome. Part 1 is, why does AI matter? Now, I'll just spend a minute on this. I think it's important for you to realize why this word AI matters so much. This is a buzzword, but it's here to stay. Yeah? If you take a historical step back, you'd realize that about 250 years ago, there was something called the first industrial revolution, where technology was utilized to create artificial power, artificial labor through steam. Heating up water, which made a turbine spin, which generated energy. This initial technology, about 250 years ago, changed really the landscape for the industry. It allowed us to create automated, it allowed us to have a lot more power to make a wind turbine, for example, or to create steamboats for transportation and other things. So this was around 1700, 1780 or so. The second industrial revolution came when they then took this technology and they said, you know what? We can store electricity. We can store energy, rather. So we can generate this energy, but then we can store it. And not only can we store it, but we can transport that energy to another place. Once you can do that, you can generate energy in one location, store it, transport it, and consume it in another location. This is essentially what electricity does. We've been then inventing electricity grids. We've all of a sudden been able to lit up the world, quite literally. Before that, we didn't have proper lighting, so we just used like lanterns and those things. So all of a sudden, we could lit up the Earth. From the moon, you could all of a sudden see the Earth at night. So this electricity was the second industrial revolution. Really was around more 1913, but like 1800s were able to start electricity. Then computing came about in 1960s. Computing was the creation of electronics, putting electronics in a circuit, creating a logic around it with zeros and ones. And as a result, we could create computers that could do certain calculations based on rules we gave them. Yeah? And as an evolution of that, we then created software and eventually created the internet. In the 60s, we created the internet, which now, the consumer internet as we know it, World Wide Web, is only from the 1990s. And that created then what all of you would know now as internet, and which allows us to do all these cool things. This is very, very recent. This is the third industrial revolution. And what's even more recent is an extension of this, is that we have mobile phones. Mobile phones are maybe 20, 30 years old for the early versions, but smartphone is only about 10, 11, 12 years old, as we currently know, the iPhone and Android. So this is all very, very recent. And what we're going through right now, which you may not realize, but it's a pretty big deal, we're going through now the fourth industrial revolution, which is artificial intelligence. We went from being able to generate labor or energy artificially, storing that, transporting that, creating computers that could do simple calculations based on the rules we gave it, and now with artificial intelligence, we don't even need to give it rules anymore. Just using data, artificial intelligence will figure out the answers, and we'll talk a lot about this. Yeah? This will go everywhere, this technology. Whatever you plan to do in your lives, it will be touched by AI one way or another. Already, we are already touched by AI. But especially if you're in the field of technology and IT, you will interact with AI more and more. Now, you can be a passive consumer of that technology, or you can be a little bit more proactive in it. Yeah? So this is, I would say, the context of this. And for a country like Cambodia, it is critical that you can use AI for good. Because if you let other people in other parts of the world define the use cases of your AI, some elements of your society may fall behind. So it's important that, as local Cambodians, you figure out how to use AI for your society. Yeah? And you won't have that much time to figure this out. We're talking the next 10 years. Yeah? So it's important that we build this community, and this is part of the spirit of what we're doing today, to help build this community, to help mentor this community and finance it. And hopefully, in the process, we'll do some amazing things together. Yeah? So, artificial intelligence is the new electricity. It's literally, in terms of the size, the importance of it, it will be like this. And it's not just about a new web technology. Yeah. So, why? I hinted already at this a little bit, but I'll talk a little bit more detail on this. Traditional software are expert systems. That means, traditionally, when you build a software, most of the people in this room, when we build softwares, we would create rules. And we program those rules with certain logical operators, and then we create an application. Think of it like an application that is in charge of taking containers off a ship, or an application that plays chess, or an accounting software, the traditional way of solving those problems, up till pretty much now or recently, is by having a human programmer or a team of human programmers identify what the rules are for this software and then program them in. That means if we as humans don't know the rules, we can't program this, right? Someone needs to have the answer. So there was a very interesting experiment done around 2004 with DARPA. DARPA is the defense research agency of the U.S. Department, which is so it's financed by the U.S. military. They basically looked at a challenge where they asked people to drive through the desert. Some of you might have seen this element of the presentation. There will be other slides that you haven't seen. If you've seen previous presentations of mine. But so in DARPA, they said, well, we're going to create some teams of individuals, and the challenge is that they have to create a self-driving car that goes through the desert for 10 kilometers. The first time they did it in 2004, 0 teams finished. 0. Because all the approaches were based on rules. They said, okay, we're going to program this desert, we're going to program the roads, we're going to program when the dunes start, we're going to tell the car what happens when you hit a rock, we're going to say what happens when you start driving up the dune, etc. And there were so many rules, tens of thousands of rules, and they couldn't factor everything. They couldn't factor all the weather in, they couldn't factor in the humidity, they couldn't factor in that there might be something wrong with the tire, etc. And DARPA was like realizing, hey, we have a real issue here. In 2005, 5 teams finished. You know the difference? They used AI. Instead of trying to figure out all the rules, they created a system that could learn on the go. This was a major breakthrough for AI and created more breakthroughs as it evolved. So if there's one thing you should take away from today is that we're moving away from a rule-based way of creating software to more database. It doesn't mean that rules won't be necessary. We'll still have rule-based software as well. But we'll more and more have elements of software will be database. So humans, in a database environment, humans don't tell the machines what to do. We just create the conditions for the machine to figure it out. So typically that means we put the data in, this is the AI, something happens here, and then the outcome comes out. The output comes out, whether it's a prediction, or it's a value, or it's a classification problem, or something. So lots of examples of this. You put the input, you get the output, the response. For email, the output can be spam, whether you label something as spam or not. For image, the output can be an object, where you identify whether it's a cat or dog. For audio, you identify whether it's a text, speech recognition. For text, you can turn it into audio, etc. Right? These are just examples, but that's the logic. So machine learning is what the majority of the applications that you hear these days are about machine learning. There's other types of AI that we won't talk too much about today. During the technical part, my colleagues will go into lots of details of this. But at a high level, in case you have to go to break, I kind of go through some key concepts. If you think of data, lots of data, well, amongst other things, some AI techniques, what they do is they cluster the data, which allows you to start identifying different features within that data, or different labels or within that data. An example would be a cat or dog. So you have pictures of cats and dogs. At the end of that, you want the AI to automatically know whether it's a cat or a dog, right? So here in a neural network, you create layers hidden layers that would identify features of this cat, or features of this picture that you feed in, and you will start realizing, you take a small piece of the cat, he starts realizing, hey, this looks more like a cat. And eventually it says it's a cat instead of a dog. So you would sort of do feature extraction. This is one method. There's many other methods, just to be clear. But this is one method. So each data classification problem is different. And that's why we need a lot of different AI models. We need a lot of different algorithms. And that's why it's quite complex. It's not just about optimizing for one thing. The data is really where the science is. So based on what data you feed in, you can see which algorithm would apply to that. As a result, it's a whole science. Yeah? Now, We won't go into too many details here, but there's different ways of thinking of those different algorithms. Well, later during the talk, some of my colleagues, Rata specifically, will talk about some of these algorithms that are probably a little bit more useful, and how to think about the classification of those algorithms. Because there's a way of thinking about these algorithms. Each family of algorithms has a certain purpose and a certain benefit. Yeah. A few examples of AI. And by the way, this presentation will go online, yeah, so it will be on SlideShare, you'll be able to find it for free. Yeah? So image recognition. You probably know this best because everyone has a phone in their pocket, so you already see that image recognition can recognize your face. Not only your face, but it can recognize emotions. So you can see, based on your features, and whether you smile, whether you're angry, what your emotions are. It can also detect your age, it can detect your gender, it can detect a lot of things these days, yeah? And it's getting more and more accurate. There's still some bias because most of the pictures are still trained either on more Chinese Asian faces or on Western faces, especially for black features. There's still some pictures missing, which is actually a real problem if you think of it. So they're training data, libraries of data on specific features. So, but we're getting there, and within a few years that exercise will be done. Yeah? In China, for example, surveillance system already allows you to check huge amounts of people in a station, automatically detect everyone. Not only their face, but also their emotions, red flag them if they are someone that you think is a potential criminal. So there's a whole lot of things already that sit against this. It's only a matter of time before this comes here. I'm not surprised if within a year this will be installed in Cambodia as well. Same for cameras. If you're driving a car that is augmented with the right sensors or LiDAR, you can already see all these different objects. You can see human objects, non-human objects, where they're moving, what their intent is. You can red flag them if there's an issue with them, and based on that you can navigate. Yeah, again, those applications are already out there. They're getting better and better and better. Within 5 years, a lot of those applications will be commercially on the roads, pretty much anywhere in the world. It will depend on the regulation. It won't depend anymore on the technology. It will depend on the regulation. Autonomous systems, this is about self-driving car. Tesla is the most famous example. But pretty much every car manufacturer is now working on this. This is a matter of life and death. If you're Toyota or Mercedes and you don't work on this, you have no future. Yeah. Email replies, you probably have noticed when you have Gmail, already Gmail allows you to pick out of a tree. I don't know if it's in Cambodia rolled out, but I think so. It's one of, I think it might be a ladder you have to activate, I'm not sure. But it already it allows you to have automatic replies. So, and Facebook does the same now, the Messenger. So it already detects what the text is, and then it can suggest replies. For example, for scheduling, you can say, let's do Monday. Monday works for me, either day works for me. And then you just have to click. It doesn't yet send a message on your behalf. That's the next level, you know? But that's only a matter of time. The AI is getting good enough to do that as well. Chatbots, you probably know this in Messenger, but chatbots are now all over and getting better and better. Again, we're probably 2-3 years away for chatbots to be mainstream in applications like banking and other things. But already now, chatbots are getting 80% there. So Messenger is quite famous because, especially here in Cambodia, people use a lot of Facebook. But so chatbot would be a computer program that chats with you in your language. Yeah? This is now an English example. In Khmer, there are still some restrictions on this, which we're actually going to talk about a little bit afterwards when it comes to the natural language toolkit, processing toolkit. But it's getting better and better. Even in Khmer, I think within a few years we're going to get there. And once we can get there, you can imagine a lot of applications that will be more efficient. So voice assistants, voice, many people say it's the next operating system. So voice assistant allows you to control things through your voice. So you can voice control your world. Now, Amazon Echo is the most famous one, but not surprisingly, all the big companies are competing. Yeah? I mean, Apple, Microsoft, Google, Amazon, they're all competing for this market because they can contextualize the world with voice, and then you can control your environment with voice. Yeah? Prediction, which is quite interesting, not many people speak about it, but obviously prediction and monitoring analytics allows us to do a lot of things, including in financial applications, fraud detection. For example, we're actually doing some things for Cambodian fraud detection as well. There's a lot of things you can do once you look at analyzing data. Yeah. And again, some of these things, the traditional way of doing those things is that you have rules, humans, but humans can only, there's only a finite amount of rules they can define. Maybe 1,000, maybe 10,000, but there won't be infinite amount of rules. Whereas AI, you can just look at your data. Right? So if you think you can ignore it, think again. Basically, we are currently living in a mobile-first world, but that's already moving toward AI-first world. Yeah? That means if you are currently designing technology or products, you're probably thinking about creating a mobile application. In the future, and I'm talking the next couple of years, and you will have to think about which elements of this will have to be AI enabled already. Yeah? Because if you're not, you're just going to be behind everyone else. So that's part one. That's sort of the business case. Yeah? If I haven't convinced you about the importance of AI, talk to me afterwards, but I think I gave you a thing of business case. So part two is, how can we develop AI engineers in Cambodia? And like I said, this is we're on a race against the clock here. If you guys want to be competitive, we're on a race against the clock. So is Cambodia ready for AI? My answer to that is very simple, yes. I gave a presentation at the ministry recently on exactly this topic, the Ministry of Telecommunication. I think Cambodians are very humble people, very modest, but you're too modest. You should probably be a little bit more ambitious, a little bit more bold, a little bit more confident about your skills. It's not that it's going to be easy, and we're going to talk about some of the challenges. But as a society, there's a lot of things you could be doing with AI. Yeah, you could create chatbots that allows us to have better customer service experiences, better training experience for your staff and for your students. You can create smart recommendations for all your consumer products, whether it's news websites or e-commerce. You can create data analytics services. You can create know your customer. So I live in Singapore and I come here every month or so, and I usually buy a SIM card. And I buy a SIM card from Smart typically. And sorry if there's anyone else, another telco in the room. So I go from the airport, I go to the Smart shop, I give my passport and I register. This is the first time I've noticed that Smart now has a KYC application. So what they do is the customer service guy takes a picture of my passport with their mobile phone app, in their app from Smart. They don't have a scanner anymore. It extracts directly all my information through OCR, and it directly puts everything in the right format, right? So this is good to see that these things are getting more mainstream. Yeah. So it's only a matter of time before those things will be everywhere, right? Even for accessing, for example, in Singapore now, what you have is many offices, they don't use magnetic access cards anymore. They use facial recognition. So you just go through a scanner, it scans your face, they notice that you're a staff member and you can walk in, right? It makes more sense, it's easier. Refugee camps in Turkey, so there's a lot of refugees that fled the Middle East recently. Refugees typically have no papers and no money. So what they did is, UNESCO, they wanted to protect some of these people. They were transferring money, but they couldn't give them money in their hands, so they pulled a blockchain system. And what they did is so it's a decentralized database, and the wallet is in your eye. So basically you scan your retina, and based on that you know your wallet value. Because all these refugees have mobile phones. So they could scan their own eye to see how much money they have in their wallet. Right? And if they want to pay, instead of a QR code, you use your eyes. So they pay with their eyes, someone. Right? So it's only a matter of time before these technologies are rolled out in more applications. But it's not rocket science anymore. We know how these things work and how these things can be done. It's a matter of creativity and a bit of skill to get this done, right? Prediction systems like frauds, different monitoring systems, mapping for routing. There's a lot of applications you can do, right? So in Cambodia, those use cases are equally necessary. There's no reason why Cambodia couldn't do it. Now, of course, the big challenge is, to do AI, you need access to data, and you need access to talent. So let's go over each. Data is obvious. As I mentioned in the first part of my presentation, AI is not about rules anymore, it's about data. So we need data. Yeah? It's a new oil, literally. And Cambodia is still a paper society, right? I mean, I think you're all aware of it. When we registered a company here, the amount of paperwork we had to go through was insane. I had to fly down several times to just make sure to put a signature somewhere because I couldn't sign virtually. I couldn't sign, scan, and then send over email. I had to physically be here to sign certain things. So it's clear that the regulation right now is still not made for it. So there's different data strategies on this, right? The first strategy is more of a mindset, and that's a conversation we have with the government, is that the future is not analog, the future is digital. So everything has to be oriented to that future, otherwise things will move. Yeah? So one example of this is regulation has to start supporting paperless. For example, to open up a bank account, to open up a company, there's still too much paperwork. That was the example I was giving. Why can't we do virtual signatures? Yeah? Digital signatures. Same for accounting. There's still way too much paperwork for that. But that's just the beginning. There's a lot of other areas where this could be improved. The second one is that the accuracy of the Khmer language processing needs to improve. It's getting better, and there's actually some of my colleagues that will speak about this later again. NIPTIC has done actually a lot of groundwork on this, but even to this day, it's probably not good enough and not exposed enough and open source enough for some of these functions to be very smooth to work with. Thirdly, and the reason why that's important, just to be clear, is because obviously in Cambodia most people speak Khmer, they don't speak English. So if you want your AI to interact with your local population, it has to understand and deal with Khmer. Right? So it's actually critical that you get this right. And no one will do this for you. Google won't do this in Silicon Valley. They don't care. Right? This has to be done for Cambodians by Cambodians. And as a matter of fact, we intend to do some work on this. So if you want to, we'll talk about this after. So we're looking for people who want to join us in that exercise. So number 3, there's data. There's already a lot of data that exists. It's not that the data doesn't exist. Now, the data may not exist in the right format, and the data might be stuck in a bank, or in a telco, or with the microfinance institutes, or it might be stuck with the government, but there's already a lot of data. So figuring out how to make that data accessible is one of the things that have to be looked at. To give you an idea, in Singapore, what they've done, the government has created a data.gov.sg website, which basically exposes all the data of the government that is allowed to be public to the public with an API, which allows developers to build applications on top of that data, which is amazing. Because once you have that, you can do a lot of interesting things. And you empower civilian innovation. Finally, there's a lot of data and a lot of tools out there that exist in the world that just can be localized. In other words, wherever you don't have the data as Cambodians or in your own society, especially when it comes to things like human features, like facial recognition, you don't need to reinvent the wheel. These things have been done internationally. Same for things like maps and those things. Some of these data models do not need to be reinvented locally. You can use whatever is done international and try to localize it. Now, I think limiting the AI skills or the talent side of things is harder because that takes more time and we have to build it from a low base. So we've sort of had a few ideas on the AI strategies. Now, maybe kind of to address the elephant in the room, do you need a PhD for machine learning? The answer for most people is no. As long as you're focusing on applied problems that other people in the world somewhere have done and solved and documented, you should probably be okay without a PhD. Now, if you're looking at entirely new solutions and researching something innovative, probably you need a PhD, but I don't think that's what you need in a Cambodian setting. And I would argue that 99% of the world doesn't need that. Yeah? There's a lot of very simple things that can be done without a PhD. And we actually will have someone from our team talking about this who has a PhD. We can give his point of view on this. I think what needs to start, though, is that you need to believe in yourself. Yeah, it's a mindset. And now, I don't mean to be rude here, but I think one thing I've noticed with my team is that in Cambodia, the mindset is not always to be hungry to do things. So you have to start by wanting to be hungry, wanting to do things. So I've been told that pangolins are quite popular in Cambodia, or at least there's a high penetration rate of pangolins. In my country, it's more turtles, as a metaphor. But pangolins are known to be a little bit lazy, a little bit slow. So if you have to be willing and interested to learn and do things, and believe in yourself and do it. Otherwise, it won't happen. Secondly, the other mindset I think is holding sometimes people back here is, and we have this, we're giving one of the courses at the university here, is that some people have a mindset of wanting to get a certificate instead of actually really learning. Because with that certificate, they think they can get a better job, they can earn more, or it's one of those rationales. Rather than just wanting to be better yourself. If you're better yourself, if you're really good, money will come. Yeah? Just want to be good first. The rest will come. And you know, you will probably get a certificate if you're good as well. But the other way around is the opposite logic. Yeah? And the third piece of that is that you need to want to learn. You need to have the hunger and appetite to learn. If you have those, a bit like a baby, you know, if you have the, I see that with my little son, who's absorbing everything I do, even things I don't want him to absorb and learn. If you, little children are learning like crazy. Somewhere, as we grow older and become adults, we forget the joy of learning. It's scary, actually. So you have to somehow dig deeper into yourself and kind of rediscover that joy of learning. And for AI, you will need, these three mindsets, because it's something hard that we're talking about. And there's not that many people that can guide you on that journey. Yeah? So, I also want to mention, like, Cambodia, believe in yourself. Luckily, there's already some amazing organizations doing amazing things here. I just want to mention STEM, which are promoting STEM skills. So I think it's amazing. I think what's amazing for Cambodia is it's a small market, and that means that even with small initiatives, you can have an impact. This, guys, is a real benefit. So if you think that because you're Cambodia, there's certain things you can't do, think again. It's the exact opposite. Because you're Cambodia, you can change things. Because you're a small country, right? So with a few people that are dedicated to their cause, and with no resistance, they just do it, and they can change things. If you want to do this in something like the UK, or like France, or whatever, it's a much bigger country, much more difficult to change things. Trust me, I'm European. So, number two is that universities can innovate. And I applaud the universities that do. We're getting more and more contact by universities. I actually want to recognize the University of Leicester, who's in a room, on innovating as well in the curriculum. I know NIPTIC is doing some amazing things. I know Zamin, there's a few universities I've heard that are doing interesting things. The Kirirom University is sort of coming up and doing cool stuff. There's more and more interesting initiatives happening, which is great. So it's about innovating that curriculum, but also for universities to engage with industry partners, because universities will only have so much of the knowledge. Because universities might be stuck in certain academic frameworks which might be outdated. So the technology is evolving so rapidly, it actually helps to start working with industry partners. So one example I want to highlight is that Slash is working with University of Leicester for a master course, which is very meaningful for us as a company. We actually have some of the class are our own employees, because we think it's useful, and there's also obviously students from the university. There's a lot of online courses, of course, like Coursera, edX. There's plenty of them out there nowadays. Knowledge. The best courses out there are not anymore in Cambodia or in university or elsewhere. The best courses are already created by some world-class professors in world-class institutions, and you can access them for either free or very little money. So we live in an amazing world where you can have the best AI professor for a few $100 from Stanford University for 20 hours for using videos on Coursera. I'm not kidding. This is pretty amazing to think of. The third piece is what we're doing here, which is that I think businesses have a responsibility to try and train the community. And again, another invitation for all the business owners in the room to engage with us and engage with other business owners to see how we can help each other. But we can invest in skills. Yeah. So Cambodia.ai is our initiative. You can check the website. It's still very basic. It will evolve. But basically, it's our initiative to try and build AI skills in Cambodia. We welcome other people to join us. This is not an ego exercise for us, so we're welcoming other companies to join us in that exercise to build skills, and we'll talk a bit more about what the community does. So it's an open source community. We're going to start with Phnom Penh because that's where we happen to be, so that's the one we can support. We want you to join in whatever format. And the way we think about learning AI is very structured. So if you think of the time to learn a skill on this axis, and then the impact you can have with that skill, or the value you gain from that skill, for AI you can break it down into 4 steps. The first step is just understanding AI basics, which is what we're doing in a session like this. The second step is that you can then implement simple tools, things like chatbot messenger, things that are existing frameworks that are already out there where most of the heavy lifting, most of the complexity has already been done by other people. It's more about configuring it, implementing it, playing around with the application, seeing how it works. But it's almost more like an application installment and configuration than actual coding. The third step is probably the hardest, and that's where we think the community can help. That's about once you think that whatever you have used as a simple AI tool does not quite fit your use case, and you have to customize it to your own use case. When you need to customize, you actually have to open up the hood and go into the code. That's where it gets a bit difficult. Yeah? Customizing AI solutions will be difficult. And that's where we're going to talk a little bit more about this later on. But once you have this, and you have this breakthrough, then you can start building advanced solutions. Yeah? We think there's very few people right now in Cambodia that have this skill set forth. There's a few people that have this skill set, and quite a few that have this skill set. And there's a few here, obviously, the rest here. We're hoping that we can, with the community, get as many people as we can to this skill set. And then those people will find their own way to get through. Right? Because we won't have enough mentors or guides. We may not be the right mentor ourselves. But so we need to get as many people as we can there, because once you have that, you can customize solutions for Cambodia. So these are 4 stages, 3 jumps. Yeah? So we want to help jump 1 and jump 2. So let me talk to you about each jump a little bit more detail. Jump 1, implementing simple tools. You probably know about bots for Messenger, existing frameworks, fairly straightforward to learn, takes a bit of time, but it's about configuration. There's other things there like sidekits, some elements that are quite easy, with AI, again, frameworks out there to build chatbots and other tools. Jump 2 will be the hard part. And to be fair, jump 1 is useful. For most of you guys, it will actually be very useful, especially when it comes to chat and voice applications. Yeah? And there will be some other applications as well that you can get from jump 1. Jump 2 is once you start having a little bit more specific needs. So let me kind of stand still to that jump 2 a little bit. If you remember when was the last time you did something really difficult, there's actually research being done on this, on what it takes to learn a difficult skill. And the way it typically works, sorry, not a curve, not a graph. Imagine this is effort, and this is the rate of learning. Typically, how you learn something difficult is that initially you make good progress. Like, it's a bit slower, but then you make good progress. And at some point you get stuck. And then your rate of learning decreases, and you feel like you're not making progress. This is the hard part. This is where the magic happens. If you stop here, you won't have learned a skill. If you continue, it makes a difference. This is typically called the valley of the death. Once you hit the valley of the death and you go past it, you get usually a breakthrough. And the fact that you have made a breakthrough by yourself or through the support network, but you made a breakthrough, allows you to become so much better at that skill. So we need to help you through the valley of death. And together is better than alone when you go through the valley of death. Yeah? Because it's a pretty lousy journey if you're alone in the desert. So the valley of death will consist of probably understanding a lot more about different algorithms. What algorithms are useful for what? So you will find that some algorithms are very high performance, like these. Some algorithms are need a lot of data, like these. Some algorithms are high performance and a small amount of data, like these. That's for supervised learning. For unsupervised learning, you would have another graph, but it's similar concept. You realize that some things are high performance with low amount of data or dimensions. Some things are basically not that high performance, but need little data. Some things need a lot of data that are not that high performance. And some things are really high performance, but need a lot of data. Yeah. So you start realizing how different things are configured and what you need to use for what application. Yeah. This is hard work. It takes time to get there. There's a few, actually we're missing some logos here, we didn't get to add them, but there's a lot of different frameworks you can start using for this. TensorFlow is probably the most famous. PyTorch, Scikit-learn, Caffe2, there's a few other ones that you can start learning. Again, we intend to work with those for the community. Yeah. So, Cambodia AI, let's learn AI together, and let's be an AI community. We have a project website, Cambodia AI, which you can find most information. The information right now is still very basic, so we're going to have more information. It was literally designed the last week, I think. His website is quite basic. We already have a dev community on Cambodia.ai.slack.com, so you can join it. And you can ask questions there. There's a general forum. We will create different channels with different groups there for questions. And then we will launch more events like this. We're hoping that other people want to do other events as well on these topics. The events doesn't always have to be content, can also be panel discussions, can be coaching, can be hands-on workshops. We're flexible. So through Startup Jungle, the community initiative for all the different events. So if you haven't yet, go to startupjungle.org, subscribe to the newsletter. You will get newsletters every month or so. And finally, we'll allocate some AI engineers to the Cambodian markets. So we hope that we can build more AI talents globally. Yeah. So that's it. You survived the first 2 parts of the talk. Look at that. Thank you.
I just present what I understand is machine learning is ability to let machine learn from data and predict the unseen data. So you just give them the data and allow the machine to predict something for us. This is machine learning. And we need to know why we learn machine learning. So there are 3 reasons that I raised in here, and I read it from the Google course. The first one is we lose time for programming. So when you do something, you always think about the rule base, how to do it, how to make a good condition. Try to find most of the condition as much as you can, and you build a perfect program. But right now, we can using machine learning to solve this problem. You give them the data, and it will generate the application for us. And one more, customized and scalable. So, assuming we want to upgrade or do another application with the same problem, but it's difficult to do. I will talk a little bit detail in the next slide. So this is simply unprogrammable task. So some problem you cannot do it by programming. Like I talked with Mr. Support, from the CEO from Morocco. So some problem you cannot do it by program. So it's difficult to find a good rule, and it's general for every situation. So for reduced time programming, example for spell checker. So here you see you need to define several rules to program. Example, you want to say the TEH. How to correct it to the THE. So you can search from the database you have from the dictionary. Okay, this word is not in the dictionary. So, and when you search the same reality in the dictionary, it gives you several of answers. Like the same of this, it can be 1,000 or 100 results for you. And how to decide which one is the best. So it's the problem. One more like love. You say LOV is the same problem, so we cannot do it by like it can be done for the rule base. You can define it, and you can experience it, and you need to ask the expert or lecturer from the literature from their language, and you can define the rule base. But for machine learning, you need only fit your machine learning model with lots of samples, lots of data. So we solve the problem. We don't need any expert about the language, and we can achieve the same problem. One more thing about the customize and scale. Example, we still do the spell checker. Our application can be predict or give the answer 100% correctly. It's good. But right now, assuming the next day we want another top 100 language. to have the same problem. Spell checker for Khmer, spell checker for Chinese, spell checker for Vietnam. So how to do it? We will learn from scratch. And we will need the expert from that language and to define the rule base. So it's not easy to scale for the product. And one more thing is complete unprogrammed task, programmable task. So like a factory condition. If I give you my photo of my face and give you to program to determine that one is my face. So can we do the programming, or what can we learn from the picture? Because in the picture is the pixel, so we always have the matrix of value. But how can we define that? That person is small eye, so it may be heaven. So we cannot program that. But for machine learning, we can do that. So we just give the picture of me, give the pictures of distance support, give the pictures of entries, and fit it to the system, fit it to the machine learning model, and we got dot model, and we will able to predict something. I give my face, and it will answer that is Kevin, or I give the entry, it will give the answer is entry. So before you start learning machine learning, I think the keyword that you need to know is few keywords. The label, feature, trend set, or validation set, and test set. Most of you maybe you never heard about validation set. You only know about training set and test set. So anyone know about the validation set? No. Okay, so first I think the label. So it is a very like the feature and label is we meet this every day, every time when we research about machine learning. And the label is something that we want to predict. Like assuming we have we want to detect we want to create the spam detection. So the spam and not spam is the label, something that we want to predict, and something that we input in the into the model and tell you the label we call feature. So if you go to a little bit mathematics, so feature is the X. Assuming we have the formulas like fx equal to ax plus b. So it's the rule, linear. Yes, it's the linear. And the x, we input the variable x because we want to know the y. So y is label, x is a feature. And translate and passate. So when we want to fit the machine, we gather a lot of data, and all of those data we not going to fit all of data to the machine, because how to know that if we fit the machine and we want to make sure that our model is good, it can predict correctly or can be predict high accuracy. So from this idea, when we have a lot of data, we need to split it into two sets. So the first set is training set, the set that we want to fit the machine. We want to machine to learn from it. And another one is evaluation set. So we want to evaluate test set is good. Our model after training is good for the test set. So we predict and give it gives us the accuracy. So if we got a high accuracy, we say that our model is good. And validation set, so I will talk later. The next slide. So feature and label again. You will face one question when you start machine learning. All the tutorial they give us is the feature matrix.
the number. But what I want to do the spam detection. And my data is the text. I collect the data from my Google email and I got this text. How can I fit to my machine learning? So this one is, we will talk about it for the pre-processing. And this one is the feature, the data that we already converted, transform it into the feature matrix. So one is represented as the spam and 0 is not spam. And W1 is the word one. The words appear in the spam, and W2 also the words appear in the email that we collect. So we have two approach for splitting the data. And the first approach that we always see is we split only two subsets. One is training and another one is testing. And second is training, validation, and testing. So why we need another extra subset? So if you see the flow here, for the training set, training model, so we fit with the training set. And we evaluation the model with the test set. So we train it one time, is that model get a high accuracy, it's not we train again. Until we got high accuracy, so we pick that model. So that model is best for that test set. And another one is we have extra validation set. So we train it with the training set and evaluation with the evaluation set. Until we got the high accuracy model, we confirm again with test set. So it's like the audit process. We done something, you teach your children, and then you can test by your own, or you have another extra person to test, or your learning process. After a teacher teach you something, he gives you the examination. Examination is the test. And then when you go to the work, another one for the interview process, they will confirm you again. Is that you qualify or not? So this this approach is just the idea we apply in the real world. So now
It's a bit good topic that I talk with Mr. Support. And for generalization and overfitting. And for the real world, we always mix with the overfitting problem. Like sometimes we hire some people and we train them the task A and task B, and when we give them the task C, they cannot do it. So it's overfitting. They only know how to do what they learn, but it's not generalized. It's not general. So if it's general, means he can do after training task A and task B, he will be able to do with the task C. So it's generalized. Like for this graph, you will see the generalization is the graph is try to it's not try to adapt or finding the best error rate for the model, but he find the general graph for the problem. And for the second graph is overfitting. He try to find the part that minimal, very small error rate. So that's why they only know the problem from the training. It's not general. So here for the pre-processing process. So like before, what we collect from the internet is the text. So we need to pre-process the text into the number. So feature instructions, so transform the raw data into feature. So what is the raw data? It has the text, like in email, it has text or string, and image. So image, we need to pre-process into the feature matrix as well. And for the GPS data, so we also find a way, or we need to find a way to extract the information from the GPS data as well. And sometimes when you see, you will see the flood detection data, you will see one stand for the time frame like 1 hour, and 2 is every 2 hours, 3 is every 3 hours, etc. So we need to find a way to convert all information. And feature transformation is the process of improved accuracy of the algorithm. So sometimes like fraud detection, it have a lot of different value. Like you do with the spam detection, all value, the value in the feature is the same rate, is the same the yes, the same scale. Like kilo, it's all in the same kilo. It's matter, it's all the same matter. But in fraud detection data, it's mixed with the different scale, like age, amount of number, amount of money, amount of time. So it's different scale. So we need to scale it that makes the feature more relevant to each other. This process we call feature transformation to make the feature more close to each other. So we are going to make to improve the accuracy in the algorithm. And one more is feature selection. So in this process, when we see the raw data, it's always have extra feature that we don't need to run or train in the algorithm. Example like the feature that has a unique value like ID. So it don't make any sense to predicting the label. So it's not have a lot of correlation with the label because it's unique value. So here we translate it like one. We count it. We call a bag of words technique. Is the techniques for transform text into matrix. And finally, we got this 11100 like this. Because why we need to transform it? Because the machine learning algorithm is about the mathematics. And if you twist the string to the mathematics, we cannot say a multiply a square. Yes, it can be a square, but a in string we cannot multiply something. So we need to transform it into a number.
It was very beautiful definition of machine learning. So let me continue by the type of machine learning algorithm. So normally, machine learning algorithm can be divided into supervised learning, unsupervised learning, and reinforcement learning. And the supervised learning is just somehow the mix between the first and the second. So I just put it here just for the definition of it. And in this session, we will focus on supervised learning only. However, I will give you a little bit to all of them. So now, supervised learning. This kind of algorithm can solve the problem like classification. You already know whether the email is spam or not spam, or verification. If you use iPhone X, when you verify your face with it, so you verify that you are the owner of the iPhone or not, and also the regression. Regression problem just like what you are going to predict, like house price or stock price. So it depends on the information that you feed or data that you feed to the model. And also depends on the problem that you're going to solve, whether it's classification, verification, or regression, and it's cross-supervised learning. So here's an example, like we have two type of, suppose that there are two dimensions, word 1 and word 2, and so that supervised learning you just learn to classify this by maximizing the accuracy that identify a given email is spam or not spam. Unsupervised learning is some kind of abstract to machine learning, like the data, we do not have the level of it, and we do not know what the inside pattern or characteristic of this data. But when we feed this data into the machine learning, we can know that the data itself actually is belong to different clusters. So the points which are close to each other are belong to the same cluster. And what the importance of this problem in terms of commercial perspective, you might want to cluster your customer into different groups. Like, so this group prefer what kind of your product, and another group may prefer another kind of your product. So when you do the marketing segmentation, that problem is very helpful for you. So supervised learning support you have a lot of data, but you just know only a portion of it. And from this data, you can divide it into different clusters, and based on the small subset of it, so you can use that level to give the value to the other data point. Reinforcement learning is more about the control system. And I don't think it's very relevant in Cambodian market right now because it's mostly focused on hardware, like robots or automobile or control system. So I think maybe we more focus on data, but not the hardware, more software. So reinforcement learning for robots is like when you train your robot and it performs on information that you train, and it gives the output whether the output is a reward or punishment. If it is punishment, it will do it again to improve its accuracy, just like when you play chess with machine. Machine, when it's just not one step finish, maybe you have 5 steps to win or 10 steps to win. But for machine, they can record each step, and you know that when I do this 5 times, I will lose. So that's punishment. So I need to change it until I win. So that's kind of problem. We use the reinforcement learning algorithm. So in this session, we focus on the supervised learning and basically the algorithm, non-bias, neural network, and decision tree, and a little bit on the support vector machine, but not very detailed, because we use this to solve a problem to detect the fraud. So a lot of applications that you can use supervised learning to solve, like text classification, like Kevin just mentioned, and also Andrea, and also spam detection, image classification, face verification, and you also mentioned in Python. Now people just use the camera to record your attendance. What time you come to work, what time you leave the office, and also what you do in the office. How many times you go to washroom. And also speech recognition Siri, you talk to Siri a lot, maybe you more interesting, this problem now, the machine learning play more and more important in medical science. So we use machine learning to predict whether someone's going to get cancer in the next 5 years. So this makes more sense than telling me, oh, today you got cancer, and your cancer type is type 3 or type 4, which is very hard to be cured. But if we can use some data and train it and predict that someone can get cancer in the next 10 years, next 15 years, so it makes more sense. And that is the next level of machine learning after we train a lot of data. And also the drug-target interaction. So reducing new drug is very expensive. But by using machine learning algorithm, we can reduce the drug production failure. And we also believe that old drug can also be used for new disease. But who's going to test one drug with all the diseases? It will take a lot of time and laborious. But by using machine learning algorithm, we can scale down our scope, searching space to smaller, and we can use this algorithm to just select only a subset of all diseases to test with a particular drug. So why we choose these 3 algorithms, non-biased, neural network, and the decision tree? Because these 3 algorithms are simple, first. Second, it works best for small data. So non-biased classifier is based on the theorem, and it's just like, okay, give me the likelihood, give me the prior and evidence, so I can know the probability that what any problem that you're going to solve. For example, like whether tomorrow is going to rain or not, based on today's weather. And based also the evidence from yesterday. So, if you go to mathematics, it's more complicated and maybe more beautiful. But maybe you need enough motivation to go through it, and which is not recommended in the beginning. And the neural network is also very traditional, but currently it's very powerful, especially deep learning. So before you go to deep learning, you should be familiar with traditional neural network. Because deep learning is just a kind of combination of a lot of mathematics, a lot of layer with deep architecture. So if you do not know the traditional or the root of it, it's much harder for you to get into. And this algorithm actually is not new at all. It's inspired by the human brain. And it's also inspired by psychology and by neuroscientists. They say that actually our brain, each part of our brain corresponding to different functions. For example, this part may be corresponding to just speaking. This part may be your sound, or maybe your voice, and vision. So actually, the algorithms that produce in our brain are the same. It's very interesting. So based on this computation from our brain, they create this kind of algorithm, and also there's a lot of mathematics behind it, but forget about it, and let's go to it, just look like this one. So normally, neural network contains input layer and the output layer. And the layer between we call hidden layer. And normally in supervised learning, the number of hidden layer or number of neurons, we call it neurons, in this input layer are corresponding to the number of features that you have for one particular record. For example, like you have spam detection system. So x1 to xn, it should be the term or the words that appear in each email. And the output will be true, spam or not spam. But maybe you have other kind of problem, not only spam document classification. Your output may be okay, like whether it's a sport or whether it is economic or politics. So the output layer corresponding to the level of the data. And there is a question always asked, how many layers do we need between here? Of course, we need to have input and output, but between how many do we need? And how many neurons of each hidden layer do we want? And until now, there is no scientific view-based practice of it, just like normally the number of input is corresponding to the feature of your data, and the output corresponding to your output level, and the hidden layer. Normally for traditional neural network, we don't put it many, maybe 2 or 3. When we increase it to 4 or 5, the performance not increased, but make the computation slow. It's different from deep learning. Deep learning normally contains much more hidden layer than the normal neural network. But the architecture is also the same. And the number of neurons of this hidden layer should be larger than the input layer, and should be also larger than the output layer. And another type of algorithm is also very traditional and very powerful, especially in decision-making process. Because this one is very comprehensive to human being, so we can interpret it. So it just looks like tree. You give me this value, how many options can I have? Give me another value, how many options should I have? And until you go to your final destination. And this algorithm is very popular in loan application, whether I should give this person money or not, whether he can turn me back or not, and medical diagnosis, also spam filtering and so on. And normally in this kind of graphical tree, like tree, and starting from root, and ended by the leaf node. And the node inside we call internal node. And the challenge in this kind of algorithm is how many internal nodes do we want, and which one should be the root. So normally, in order to compute or to define or to use one variable as a root and as a hidden layer, we need to compute using the information theory algorithm, which are called usual information, Gini index, entropy, and there's more advanced, mathematical advanced. So just forget about that and just the decision tree is just very useful for interpretation rather than the decision of the neural network and layer bias. Because in this one, after you obtain the algorithm, you show it to your customer, you show it to anyone, they can understand it quickly and easily. And the next session, we're going to show our demo and let Kevin.
So normally you heard about the notebook, the node. So normally you heard about the notebook, the note from your mobile phone, and you can note something, and you can see it later. But with Jupyter notebook, you can note something and you can run the code. So this is the good notebook ever. Okay, so here's the small example, small demo about the chatbot with English language. So let's have a look a little bit about the data set. So you can find it in data set, and chatbot. So here the data set. You define the tag or the categories, the sentence that that meaning about goodbye in the goodbye folder, and the same thing with greeting and thanks. So goodbye, you will see. And another one. So all the sentence that means similar, that means goodbye, and we define in the goodbye tag, goodbye folder. And one more is greeting. So hello or hello there, good morning, like this. So we say in greeting, from greeting. So on this example, I just search from Google. I just search common greeting in English, and I copy it into my dataset. And you can have a look further in this folder later. Let's go to the demo. So here, assuming I say goodbye. So the goodbye is feature 1, feature 2, and feature 3. And goodbye is the label. And the same thing, see you, the label is goodbye. Thank you is label is thank a lot, or thank you very much. It means the same thing. And when you want to run it, you just hover in the left corner, and you will see the run itself, or you can click this one. And this one, the ML. So ML is the machine learning. It is created by Cambodian young team. So we built 3 algorithms from scratch. The knowledge base from Mr. Rota, so we work with Mr. Rota to implement it from our own. And it's also for ML, why we build ML is not a competition with another machine learning library. We just want to share the knowledge, and it's the basics. Like we need to know some basics of the algorithm,
And if you go further, you will sometimes you want to see the code, sometimes you want to see the calculation, etc. So we build this for the purpose of learning. So get answer. So I built a function of get answer, assuming my model predict that the user say greeting to me. So how can I respond to the user? So I have the predefined answer for the three types of answer. One is greeting, so I will say I am chatbot, nice to meet you, and goodbye, thanks for chatting with me. Thank you so much. See you again. Like this. Or you can answer different questions and you can take it randomly because you don't want your chatbot to talk to answer the same question every time when we chat with the chatbot. So you can always define several answers and then you can pick one for. And this one is the pre-processing process. So as you can see, the data set is in the text, and you want to put it in the machine learning. So we need to pre-process, convert it into the feature matrix. And this process we call pre-processing. And in the config, we need to define the path for database for the dataset. So dataset chatbot is my dataset folder, and dataset is the after I pre-processing, I will store it in the data matrix folder, and backup. So we have the dictionary that stored in this, and training model. So the training we always want the model from training. So after training, we take that model to use in another application. Sometimes you can use it in your application API, your mobile phone, etc. So we don't need to train it every time when we want to predict something. We just train it, we pre-train it, and it takes that model and predict something. So it can be used the time. And now I already pre-process and forget about all of these parameters because it's also a bit complicated about the pre-processing process. So about the extraction feature from the text, we have several techniques like backup word. We use frequency, so we need to take we need to design our dictionary for transforming into text. So we just say, okay, I use the techniques of frequency, and I don't care about each class, so I care about all. So I care about when we train. So the data that that somebody puts into the train. So I don't only care about that. And I take one. So for the feature selection, so you cannot take all the feature, and you think about all those features is related with the level. So if you take all the feature, it can be reduce your accuracy, like feature selection and feature transformation is the process that we want to improve our algorithm model. So if you have the right data set, but you don't pre-process it in the right way, you cannot achieve the high accuracy for your model. And here, after you pre-process it, so in order to learn it and sell time, so we pre-process it and sell it into CSV. So after that, we can take that CSV that you always see when you start in machine learning. You always see 1 and 0. This comes from the dot frequency.csv that every data that they teach us, they already pre-process it because they don't want us to care about so much about the pre-processing process because it's too much complicated. Like anything that we care about a lot, so we don't care about the basic and we will stop learning it. Maybe a lot of information that you want to get. but you don't understand. So they just hit this step later. And now the process of choosing algorithm. So we deal with three algorithms. The first one is Nile-based, neural network, and decision tree. So we just choosing and we initialize the machine learning and we pick one algorithm to train. So now the process of training. So when you training, you need to divide into the data into two subsets or three subsets. And later I will show you why we have another wide data set, why it's necessary, and how to, and why it can be improve our development or evaluate that our model is the best. So in this process, we only split the data set into two subsets. And now I take the I take the training set, fit with the train process. So I put it to the train here, and after train I get a model. So when I predict, I need the model from training and predict with our test set to evaluate our model that we have been trained recently is good or bad. So after that, I will see the accuracy here. Is there accuracy satisfy you, or you want to train it again to test the accuracy? So if this accuracy is still low, you can run it again until you get the high accuracy that you want. And assuming I choose this model. Okay, now control here. Now I make an application called Chatbot, and I don't need to train it again because I already trained it. What I need is I want the model that has been trained before. So I lost the model. I choose the algorithm, and I lost the model from the model that we has been trained. And I put the loop here because chatbot always we ask questions and we do it again and again. And this is we need to translate again because the data that we put from the user is text. So assuming I say hello. Okay, so I need to transform this text into the feature matrix that's 0, 0, 0, 0, 1, and 0, 0. So I want to translate into this. And now the model predicts it was greeting. So if it was greeting, I will answer I am chatbot, nice to know you. Like and you can say thank you so much, see you again, see you later. So it's understand what we are talking about. Or we say how are you? So this word I never trained it. So he say goodbye because he don't know. What I tell him is only three type of category of meaning. But I say how are you? How can they know? Maybe we can add another type of asking like I would say like another type of meaning. So you can just add in the training set, and your chatbot will be able to answer the question. And you just design your answer what you want to do. So here's the English chatbot. And now, if you want to do with the command language, how can we do it? So it's come from the question one, the reason one, and to the reason two. We want to scale it, we want to customize it.
So I just change the data set. And everything, every code is the same. I just changing the data set. And yes, the thing is that it can understand my language. So I translate from the English answer to my answer. Pre-processing is the same, nothing changed. The change is the reference of the data set. So I put it in chatbot K. And this is the parameter that we need to change. So is that Unicode or is that English language example? So for my language is English, is the my Unicode. So I say true. And the same thing with pre-processing. I train it, I choose the algorithm. After that, I train it. I got the accuracy. Is that accuracy satisfied you, or you want to train it again to have another model? So okay, so this one is better. So I choose this model. Okay, so now I chat with it. Okay, its answer give me greeting. So I can answer Tuesday trong chi chatbot greeting not that mascot or it say okay, it says thank you or say bye. It's a goodbye. So the same problem, we just tweak a little bit in the data set, and we can scalable and customizable with the same solution. So it's the power of machine learning. Or you can translate into several language easily. Or right now we can, like this language you don't know, so you can use for translate to translate your data set. And now you have another language of your chatbot. So yeah, it's all about the chatbot. And one more demo. Document classification. So it's similar. One is we classify the sentence, and then one is we classify the document. The document is contain a lot of sentence, a lot of words. So it's the same problem. We just have different issues. So we train this again. We only choose. We can only change the data set. And now my model here, and I testing with the one sentence that I take from another. So this one I just create my own. So my own is machine learning library that created by young Cambodian AI engineers like this. So this sentence or this document demonstrate that it's talking about the AI. Assuming you want to build you have a lot of you want to build a new like result from Milo, and you have a lot of you can have a lot of source, but without knowing what kind of that's new, and then you want to classify it. And assuming we have like 10 or 20 new every day, we can use for one person. They read it and they can classify it. Assuming later we have several new in one day, so we cannot able to do that task with one person. Maybe we can hire more person, but it's not a good idea for the budget. So we need to spend a lot of time for the same task like this. So maybe we can use AI or use machine learning to classify for us, automate tagging for us, and it's a more the better solution for this issue. next demo is fraud detection, will present by Mr. Rocker.
Thank you so much, Kevin. And for now, we're going to look at an interesting problem, which is fraud detection. And normally, this kind of data is very sensitive data, and we do not have this data. So the data that we use here is the simulated data. It's simulated by the machine, but based on the business aspect, not just nonsense randomly generated, but it's based on the business process. And the data is available online, and it is used by a lot of researchers for this field to do their model training. So actually, it's basically similar with the text classification. We have the training, we have the testing, we learn the model, and almost exactly the same. Not exactly, but almost the same. So if you get one idea from text classification, you can learn others very quickly. And it's just like here. So I will show you. This is the data that we have. So in this data, there are 11 columns, and each column corresponds to different feature or characteristic. Like one is step 1 to 2, one is in 1 hour, and the dissection is 1 hour, and the row here, this is called row, and this is called column. So the first column, step here is the time of the dissection. And the amount is the amount of each dissection. And overbalance, new balance. So overbalance means before the dissection, and new balance is the balance after the dissection. And this balance is of the sender. And another balance of the destination that you transfer your money to, or you buy a product from that account. And the last column is the level one. One is fraud, and the 0 is not fraud. And this data contains about more than 1 million records, which is so much. And actually, I already removed some columns which identify who is going to send money to who. So the identity of the sender and receiver I removed. And we keep only this number called training model. Since the data is too much, the 1 million, and I do it on my laptop, and of course it's out the capability of this laptop, and I just use the sampling technique just to randomly select subset of the total data for the training. And among this 1 million record, the transaction only about 1,100 records. So if you compare it in proportion to maybe 0.01% or maybe less than that, but imagine that if you have a million transactions a day and only just a very small of it as fraud, so how many of your customers are going to get away from your service? Because they feel not safe with you when a lot of accounts have been hacked or have been stolen the money. So here, okay, let me show you here. This is the feature processing, the pre-processing. So I do the scaling, and I randomly select the total report into testing and to training. Why we need to do that? Normally, in order to create the model, so in order to do it, we need more testing data, right? But if we don't have testing data, we can only use our existing data to divide it into training and testing. So testing data is not involved in training at all. So you use only training data to train your model, and use the testing data to test the effectiveness of your model. So I'm going to go to okay, here is the random process, select some of it. And here I remove the testing data from my training data. So I contain two sets of data, one is training set and testing set. So here, okay, here I scan the data like Kevin just said. Because when we look at the data, here we look at the data, this set contain only 1 to 15, maybe 20. But if you look at the amount, it may be million or more than a million. So when you feed this raw data into your machine learning algorithm, it may give a lot of weight to this feature, but a very little weight to this one, and also maybe to this one. But actually, they all equally contribute to your model. So in order to make them, to make every of them give a fair-wise vote to the model, you need to scale it. And that is the pre-processing technique. So after we scale it, we can train our model and we can predict it. So let me go through it. Okay, so my accuracy is 95%. And here I did it with many, not only one simulation. So as I said, because the data contains 1 million records, and I do some systematic process. Just I select only 40,000, 20,000, 10,000, and 5,000. All the total record to do the process. And among these records, I select 200 of it, 400 of it, 600 of it, 1,000 of it to be the testing data. So when you see this figure, when we select more data, the performance becomes lower comparing to the other. Because remember that we have only 1,000 records are fraud, and the rest are unfraud. So when we select more of them, the balance of these two classes are not well balanced. Like a lot of data are non-fraud, and only a small of them are fraud. So that is why when we select smaller of them, the performance is better. Also, when we increase the number of testing data, so our testing data contains more than 1,000. When we take 1,000 of it, it left only a few records, maybe just 200 of it to be the testing, so that to be the training set. So our model cannot learn the pattern effectively. So that is why in the fraud detection system, we need also model some technique called statistical learning, like sampling. Because remember that every day we have million of transactions, and only just a small of them are fraud. So if we compare these two, or we use these two data to train our machine learning algorithm, the algorithm may not perform very well because the data from the non-fraud is too heavy, too much, comparing to the fraud transaction. So we need to do sampling, and then we need to do the feature selection, just like Haven said. We choose the best model that can take our data. Thank you so much. So next.
So my is now compete with another very powerful machine learning library like TensorFlow, PyTorch, Keras. So it's about foundation machine learning. So you can have a look and finding the basics mathematics, how to implement in the real algorithm, what is the training process, and after that you want to classify what is the model, what you're gonna save the model after calculation. So you can have a look in the GitHub, you can search MyML, and it's available in the Python package management. You can say you can type pipe install Khmer, so you can play it. And new test, so every time when we test something, we always test with the something else or another country or another non-Cambodian people created. But now you test something with Cambodian created, so it's about Khmer. One more thing is support you. So we have you never see the machine learning libraries or predecessor of the Khmer language, but it helps in the Khmer map. One more is the OCR Khmer word. So it's from the Sawatna, so it just inspire us about the OCR technique that normally if we want to improve the accuracy, we try to collect a lot of font, a lot of example to the machine learning. But right now, why don't we create the preprocessor that can preprocess only the skeleton of the word? Assuming we have like the bowl or my move, like my OS, every font. So we just need only the skeleton, like only one line of that font, and we feed to the machine learning. And when we preprocess, we also do the same step. We take only skeleton of the word and we classify it. So this kind of technique, we don't care about many font, or maybe later we have another modern font, or you draw a little bit different from the original font. So we need to train it again and do it again. One more thing I think is useful for Cambodia is Khmer ancient Khmer word. So if you see in the old ones, no one can read that word, and only little lecturer or professor who is expert about the Khmer language during the 12th century. So it's difficult to read that meaning, and no one can prove that all those meaning is correct or not. It's from this person, from this expert person, so they just explain it to their way, and we never know. Assuming we achieve it and we go further for the class OCR with the ancient Khmer word, so it can be useful, and this knowledge can be left for 1,000 years. Because human can be died, but machine cannot die. You only store the model, and then you can use it for the next year or next 100 years. And local discussion community, we have Slack, so you can go to Cambodian.ai.slash.com and join. Meet up at Slash office. So you can also ask for the meeting. We can have a small talk like we talked today. So we have a small meeting like, okay, I have this question or that question I want to ask. So we are not expert, and we are not answer all those questions, but we will ask something else in the community or something else from expert in the machine learning field, and we try to answer the question, and we capture all those questions, put it into one place, and later on everybody can have a look with it, so we can improve by that. And created by Khmer. So it's now we have a good test from machine learning Khmer. So the next slide is from Mr. Magran, so he will talk about it. He will organize on the community. Thank you.
Okay, thank you, Kevin. Thank you, everyone. So I would like to introduce you our community. So currently we have two. One is Cambodian AI and another one is MyML. But inside the Cambodian AI, there are many libraries and the products we are working on. So we regard Cambodian AI as a community. So in our Cambodian AI community, we have the open source MyML, we have chatbot Lisa in English and Khmer talking about the visa data, image recognition, sentiment analysis. With my OCR, we are going to work on it in the future, and we hope the contributors will contribute more in this open source project and other AI project events. So any events related to the AI or the project, you can post on the Cambodian AI. We just initiate the community. I think you have your own open source project or something or event, so we can contact and do the partner with events together. So here, what is the Cambodian AI? So it is where the community where you can learn and to promote the AI project or events in Cambodia. So we Slash initiate the Cambodian AI, but everyone can join, any companies or the organizations. And currently we have the following projects as I mentioned, and also Cambodian AI is also doing the AI course at the University of Slash.co as well. Currently we are doing the AI course on that. So yes, rather than the events, the open source project, we are also doing the training to help the community learn more about the AI. And yes, we have currently we have a basic website. So if you're interested, please do visit our website cambodian.ai. So and also if you have any questions and if you are the expert or you know a lot more about the AI, so you can have also answer the questions in the Slack community. So we have Cambodian.ai.slack.com communities where you can ask the questions and someone who knows can answer. Yes, we have a community grows about AI. So currently we are doing one open source project we call MyMap. So we open source that project to solve the complex problem in Cambodian society, and also is there for us to get started learning the AI. So it's just like you are a beginner, so or you want to get started, so have a look at the MyMap. But if you are the expert, please come to contribute more and have this open source bigger, and it is more improved. So you have any additions, features would like to add, so you can contribute more. So currently we have three algorithms inside of MyML for everyone to learn and test. We have 9 ways, neural network, and this is 3 algorithms, and one reason will be additional. So I hope that everyone can join and have a look and contribute. So here is the link on our GitHub. You can see /d for MyML. And for the Slack community that dedicated to the MyML. So currently we have Cambodian.ai.slack, but we have another channel that MyML, so dedicated to the open source. So yes, you can have questions, would like to share, want to add more ideas or features, please go visit the Slack channel of MyML, yes, and the GitHub, please. So how you can contribute to the Cambodian AI and MyML? So you can subscribe to our Cambodian AI main list through our website Cambodian AI, and also you can book the appointment, like request the appointment with our AI team. So suppose that I would like to join, but I am just would like to get started, but I have some questions or something that I do not understand to get me started. So you can book a meeting with us. So we will spare some time, and then we try to explain more how the project works, and after that how you can contribute more. So you don't have to be the expert in order to contribute. Even though you are a beginner or would like to get started, so please book the appointment with us, and after that, yes, we can talk to learn more about it. And then, yes, Cambodian AI Slack, we have that. So yes, share questions or whatever you would like to share, or when someone has questions, can answer them. And this one is still the same, yes, and channel inside that. And then yes, you can be speaker. So it doesn't have to be Slash or anyone, but anyone who knows about the AI who would like to share the knowledge, share something, the AI to make the community grow bigger. So please open source project or event, if you have your own, because currently we just initiate the idea, so most project is from Slash, but we would like to see more open source besides Slash. If you have your open source project and would like to share, just suppose that Cambodian AI is just a community, it's not belong to any company or something, but we just initiate that and we hope that if you have any projects that related to the AI, please post on our website, or you have any events related to the AI, I would like to broadcast to the Cambodian people, to the young learners to learn more about this. So please go to the Cambodian.ai and then we can share the events and post the events together. Yes, thank you. One more thing we have, we share the paper with you to give us the feedback to make the next event more fairer. So please fill it and please